Do dementia and Alzheimer's happen simply because of bad luck? Or are they an unavoidable part of aging? The truth is more unsettling, but also far more empowering. The biological processes that lead to cognitive decline do not suddenly begin when someone starts forgetting names in their 70s. In many people, the underlying damage begins 20 to 30 years earlier, quietly and gradually, strongly influenced by daily lifestyle, especially diet. A growing body of research now links Alzheimer's disease to impaired brain insulin signaling and chronic metabolic dysfunction. For this reason, some scientists have informally referred to Alzheimer's as type 3 diabetes. While this is not an official medical diagnosis, it reflects an important observation. The brain's ability to use energy becomes disrupted long before symptoms appear. Two major mechanisms help explain this connection. First, brain insulin resistance. Your brain uses roughly 20% of the body's total energy. When insulin signaling in the brain is impaired, neurons struggle to access glucose efficiently. The fuel is present, but the delivery system no longer works properly. Over time, this energy crisis affects memory formation, learning, and repair. Second, chronic oxidative stress and inflammation. This is the biological equivalent of internal rust. Excess free radicals and inflammatory signaling damage neuronal membranes, mitochondria, and synapses. Communication between brain cells becomes slower and less reliable. With that foundation in mind, here are the dietary patterns most consistently associated with higher long-term risk for cognitive decline. Number 1. Liquid sugar and sugary drinks. The greatest sugar threat to the brain is not dessert. It is liquid sugar. Soft drinks, energy drinks, sweetened teas, and even many bottled fruit juices deliver large doses of rapidly absorbed sugar without fiber to slow the response. This causes sharp glucose and insulin spikes, which are strongly linked to insulin resistance over time. Large observational studies associate frequent consumption of sugar-sweetened beverages with reduced hippocampal volume and poorer memory performance. The hippocampus is one of the first brain regions affected in Alzheimer's disease. Number 2. The light trap. Aspartame and artificial sweeteners. Switching to diet or zero beverages may reduce calories, but it does not necessarily protect the brain. Artificial sweeteners such as aspartame are linked in several large population studies to higher rates of stroke and dementia. The mechanisms are still being studied, but evidence suggests they may interfere with glucose regulation, gut-brain signaling, and vascular health. The brain detects sweetness and prepares for incoming energy. Repeatedly pairing sweetness with no metabolic fuel appears to disturb normal metabolic signaling. Number 3. Processed meats, the pink poison. Bacon, hot dogs, sausages, salami, ham, and most deli meats are preserved with nitrates and nitrites to enhance color, flavor, and shelf life. Inside the body, especially in the presence of high heat and stomach acid, these compounds can be converted into nitrosamines, a class of chemicals known to be neurotoxic and carcinogenic. Importantly, several nitrosamines are able to cross the blood-brain barrier, where they interfere with mitochondrial function, increase oxidative stress, and promote chronic neuroinflammation. 3 key processes involved in neurodegeneration. Beyond preservatives, processed meats are also typically high in advanced glycation end products, AGEs, and oxidized fats, both of which accelerate cellular aging and intensify inflammatory signaling in brain tissue. This combination creates a biochemical environment that favors insulin resistance in neurons and disrupts normal synaptic signaling. Large long-term cohort studies consistently show that people who consume higher amounts of processed meats experience faster rates of cognitive decline and a higher incidence of dementia compared with those who eat little or none. In contrast, fresh, minimally processed meats, such as unprocessed poultry, beef, or fish, prepared without curing agents, show a much weaker association, or no clear association at all, with cognitive deterioration. This strongly suggests that the neurological risk is driven not primarily by meat itself, but by the industrial processing methods and chemical additives used to preserve it. Number 4. Industrial seed oils and deep-fried foods. Corn, soybean, sunflower, and similar industrial seed oils are widely used in ultra-processed foods and commercial frying because they are inexpensive and flavor-neutral. These oils are rich in omega-6 polyunsaturated fatty acids, especially linoleic acid. Although omega-6 fats are not inherently harmful, modern diets supply them in disproportionately high amounts, creating an imbalance with omega-3 fats that pushes the body toward a more pro-inflammatory state. This chronic inflammatory signaling does not stop at the joints or arteries. It also affects the brain. The problem becomes far more serious when these oils are repeatedly heated in deep fryers. Polyunsaturated fats are chemically fragile, and under high temperatures and prolonged exposure to oxygen, they rapidly degrade, forming lipid peroxides and highly reactive aldehydes such as acrolein and 4-hydroxynonenal. These compounds are absorbed after a fried meal and can circulate to the brain, where they damage proteins, receptors, and cell membranes. The brain is uniquely vulnerable to this type of injury because it contains large amounts of delicate polyunsaturated fats and consumes a very high level of oxygen, making it a prime target for oxidative reactions. Aldehydes generated from overheated seed oils can impair mitochondrial enzymes, reduce neuronal energy production, and chemically modify synaptic proteins, disrupting how brain cells communicate and adapt. Over time, this accelerates neuroinflammation and weakens the structural integrity of neurons. The issue, therefore, is not fat itself. Your brain is largely composed of fat and depends on it for membrane structure, signaling, and plasticity. The real danger lies in the quality, industrial processing, and heat instability of the fats being consumed. Choosing more stable fats for cooking and minimizing deep-fried and industrially prepared foods significantly reduces exposure to these neurotoxic oxidation byproducts and creates a far healthier environment for long-term brain function. Number 5. The fish paradox and mercury exposure. Fish can be an excellent source of omega-3 fatty acids, which support synaptic function and reduce neuroinflammation. However, large predatory fish, such as swordfish, shark, and some large tuna, accumulate significant amounts of methylmercury, a neurotoxin that can cross the blood-brain barrier and persist in brain tissue. Smaller, short-lived fish, such as sardines, anchovies, herring, and smaller mackerel, generally provide high omega-3 content with much lower contaminant risk. Number 6. White, refined carbohydrates. White bread, refined pasta, pastries, and many baked goods behave metabolically very similarly to sugar. They produce rapid glucose surges, repeated insulin spikes, and, over years, contribute to insulin resistance and vascular damage. High glycemic diets are associated with poorer memory and a higher likelihood of cognitive impairment later in life. Replacing refined grains with vegetables, legumes, and intact whole grains improves metabolic stability and supports brain energy supply. Number 7. Trans fats, the fake lipids. Industrially produced trans fats, still found in some margarines and processed baked goods, are structurally abnormal fats. They incorporate directly into cell membranes, including neurons, making those membranes more rigid and disrupting receptor and ion channel function. Several studies have linked higher trans fat intake to worse memory performance and increased dementia risk. Number 9. Packaged snack foods. Chips, crackers, biscuits, and similar packaged snacks are particularly damaging because they combine several high-risk factors at once. Refined carbohydrates, industrial seed oils, added sugars, salt, and flavor enhancers that encourage overconsumption. These products are a hallmark of the ultra-processed food pattern that is consistently linked with poorer cognitive aging. The encouraging part is neuroplasticity. The brain remains capable of forming new connections and strengthening existing networks when metabolic and inflammatory stress is reduced. You do not need to change everything at once. Replacing even one habitual item each week can meaningfully shift long-term risk. Number 10. Excessively salty processed foods and chronic high sodium intake. A 10th, often overlooked risk factor is chronically high dietary sodium, particularly from processed and restaurant foods such as instant noodles, packaged soups, frozen meals, fast food, and savory snacks. High sodium intake contributes to hypertension, arterial stiffness, microvascular damage in the brain. Cerebral small vessel disease is one of the strongest contributors to vascular dementia and also accelerates Alzheimer's pathology. Even in people without diagnosed stroke, long-term high blood pressure quietly damages the tiny blood vessels that nourish memory-related brain regions. Reducing heavily salted processed foods and increasing potassium-rich foods such as vegetables, beans, and fruit supports healthier cerebral blood flow and long-term cognitive resilience. Your future memory is shaped far earlier than most people realize. Each small dietary correction lowers metabolic stress, reduces inflammation, and gives your brain a better environment in which to maintain and rebuild its networks.